Hi, and welcome to the last day of your machine learning course, where we look at mastering Kaggle Titanic computation using random forest. In this section, we will look at possible solution to yesterday's assignment. We look at decision trees and working of a decision tree. We look at ways to improve a decision tree, and we will see what is a random forest and what's the advantage of using random forest. And we will end the section with a weekend task of taking part in a machine learning competition and using all the skills that we have learned so far in solving the Titanic Kaggle competition. Now let's start our section 7. In this video, we will review our Sentiment Analyzer Artificial Neural Network exercise. To complete the assignment, we need to first download the data from course GitHub site under section 6, movies.txt, and import the data into the notebook using pandas library. We remove the stop words and create a bag of words feature matrix. After creating a feature matrix, we then split the data into train and test and independent and dependent variables. We then train a neural network. Next, we print out train and test accuracy and the confusion matrix to see a precision and recall values. So let's take a look at the possible way to go about solving the exercise. Here I have opened the Sentiment Analysis Artificial Neural Network Solution notebook. The movie review dataset that we are using for this assignment is obtained from University of Michigan Kaggle competition. As always, we start by importing unnecessary libraries. Here, we are loading the NumPy library. We then load the pandas library as we will need to handle the data. We import count vectorizer for feature extraction and to convert the reviews into a bag of words features. We then import MLP classifier from Scikit-learn. The neural network is also known as multi-layer perceptrons, therefore the name MLP classifier. The other libraries we import are accuracy score to get the accuracy, confusion matrix to get the confusion matrix, and classification report to get values of precision and recall. We also import cross-validation to perform cross-validation. Next, we import the movies dataset and name the first column as sentiment and the second column as review. As you can see, the data contains zeros and ones for the first column representing negative or positive sentiment associated with the review. The second column is the movie reviews. We then check the shape of the imported dataset to check if we have imported correctly. We then use count vectorizer to convert the reviews into a bag of words feature matrix and store it in the variable xCount. We first initialize the count vectorizer and then pass it the review data. Let's first check how our neural network is performing without removing the stop words. We split the data into train and test by passing xCount and the sentiment labels. We then initialize the neural network. Here, we are having a regularization parameter as 1 e to the power negative 5 and the number of hidden layer is 2. The first hidden layer has 5 units and the second hidden layer has 2 units. We then use the fit function to train a model. We use a neural network to make predictions on the training data. We get an accuracy of 1, indicating we get nearly all the predictions correct. When this happens, we should be skeptic and always check for overfitting. We perform cross-validation to check the validation score and we get a score of 0.99. So we can assume that the model is not overfitting. Though another thing that I would like to mention over here is that the data we are using for this is simple and is containing very few examples and a small number of vocabulary of only 2000 words. So the small model may not work if the review contains more than 2000 words. Now let's see how our model performs with stop words removed. To remove the stop words, we pass in the parameter stop words equal to English to the count vectorizer by initializing it. We then store the feature matrix in xCount. Here we split the data again with a new set of features. We then initialize the neural network. Here, we are having a regularization parameter of 1 e to the power negative 5 and the number of hidden layer is 2. We are using the same number of hidden layers and the same number of units in both the hidden layers. The maximum number of iteration here is 1000. We then use the fit function to train a model to get a train and cross-validation accuracy. The train and cross-validation accuracy is 1 and 0.99 respectively. So there wasn't much difference by removing the stop words. Let's see the confusion matrix and the classification report. We can see from this confusion matrix that our model got all positive sentiments correct, but classified 13 negative sentiments to be positive. Looking at the precision and recall score, we get a precision value of 1 and a recall value of 0.98.